I've done a few videos of this high tension kicking coil, but I think it needs something really with a lot of description because it is something unusual. The coil's powering just a typical pancake coil. This is not a very low frequency, but around 700 turns. The power supply is something different. This is a kicking coil or a self-induction coil, and this is typically something you'd see in the old violet ray machines where they were run from low voltage. And the idea was that as electricity flows through this self-induction coil, which is really just a large electromagnet, there's a set of contacts that open like this and the circuit becomes broken. And when the circuit's broken, the magnetic field in the core of the coil collapses and induces a back EMF, or a kind of a high voltage pulse that's used to charge the capacitor and then discharge through the Tesla coil. It was commonly a way of making portable Tesla coils that would run from either AC or DC back when the power in homes was sort of a non-standard thing. There's no telling what they were. But this setup, to make it a little bit different, rather than run it from 110 volts, I'm running it from 1000 volts directly from a transformer. Now it's kind of seems silly. If you have a high voltage transformer, why would you need a self-induction coil? Well, it's kind of a low high voltage, only 1000 volts. To quench that sort of spark gap with that low voltage, it requires a lot of precision machining. And this self-induction coil, it's going to act the same way. So whenever the circuit's broken, it's going to induce a little bit higher voltage pulse, which is going to be a little bit easier to sustain in the gap and to handle to power the apparatus. Now, what's a little bit unusual, when you run from low voltage and the gap or the interrupter, pretty much when it opens, the circuit's closed instantly. When you run it from high voltage, as the gap opens, it actually functions as a normal spark gap for a short while and then opens beyond the 1000 volts of the transformer, and then suddenly the self-induction comes into play in this and induces a higher voltage pulse, which kind of keeps the gap going. And eventually it opens large enough that no discharge occurs and magnetism ceases completely, and the interrupter springs back into position and makes contact again. So it's kind of a complicated circuit. When it operates, it sounds almost like a hit and miss engine because you have this sort of sputtering that occurs at the gap, or the interrupter rather. Now, to complicate matters even more, I've added a small micrometer spark gap here, which allows the voltage to always be present in the coil. So normally when the contacts close, there's a brief period of inactivity. But since it's powered by 1000 volts, this spark gap will actually allow something to be happening at all times in the coil. This coil, when it operates, there's several sequences of events that's happening in the same time in the coil's operation. So there's certain long cold sparks that are a result of the self-induction, and there's a hot flaming arcs that appear because of the spark gap, or the moment when the contacts open that it functions as a spark gap here. So there's sort of layers of events happening, and you can hear in the output of the coil, there's a lot happening at once. You hear this sort of bizarre sputtering sounds that come out of it. Now for the video, I'm going to adjust the camera to where you can see the discharge, but you can also see the interrupter over here and the micrometer gap here. I'm going to start off with the micrometer gap completely closed. And I'm also going to hit the lights. You should probably be able to see this still in the dark. But when I first turn it on, you can see a sort of sputtering and strobing at the output. brushed discharge is actually going all directions. The other interesting thing about this coil is that there's a brush discharge that's sort of independent of the spark. Normally when you draw a spark, the brush will cease immediately. Here you can see I'm drawing a spark and there's still a brush discharge there. Yeah, very small amount. You can start to hear a change. And as I move closer, you'll see a real flaming discharge there. It's actually white and yellow to the eye. And this is because of that small spark gap. There's power being sent to the coil constantly, regardless of how the interrupter is operating. As I open that gap more, the total discharge length decreases because the self-induction of this sort of becomes less because part of the energy is being used in that gap. But you'll still see some of the effects of self-induction as well as a much higher discharge. Now further modifications of this can be made by adjusting the tension on the interrupter. If I loosen this interrupter a bit here, you can see more of a sputtering effect. Sparks become less continuous, but also the brush and the sparks both have many more branches added to them. Now I'll do the opposite by actually putting more tension on the interrupter. discharge is becoming really nasty at this point. For reference, this is a true flaming arc coming off of the coil. A lot of heat can be felt from even that brush discharge. By closing the gap a little more. Now you see more of a hot brush. The color of this to the naked eye is actually violet with tinges of orange and yellow. This discharge is relatively quiet. It almost looks low frequency. Distance, the naked eye is pure fire, what you see. So with one apparatus, you can get a whole multitude of different effects. And a lot of the effects are based on the fact that there's many things happening at once in this coil. There are times when you have fairly high voltage, low current pulses. There are times when you have very high current, lower voltage, sort of 1,000-volt pulses. There's times when the discharge circuit is actually where the voltage of the spark gap is changing as sometimes the interrupter is opening and it acts as a gap. It's not a very consistent discharge, but yet you get a multitude of effects that are really interesting. And with this simple setup also, 1,000-volt transformer is something kind of difficult to use normally with Tesla coils just because of the spark gap. By adding this sort of interrupter, and this interrupter is, there are 2 aluminum heat sinks and it's 1¼ inch tungsten contacts. By having sort of a pulsing interrupter like this, it doesn't get hot. I mean, I can reach down and touch it, no problem. You're able to sort of handle these high currents. in a way that might be difficult with just a fixed gap. And still, by adding such a small gap like this to the circuit, you can modify these sparks even more. So it's kind of an interesting setup. There were a few early X-ray machines that we've never actually seen any up close, but that they sort of tried to combine an interrupter and a spark gap together, and I'm guessing the output was pretty similar to this. The discharges here, especially during the end of the video, they were extremely hot. To the naked eye, they're really, you can see the violet going across, but you see yellow and orange flames coming between the terminals. And you can feel the heat, but ironically in this, you don't feel as much heat as with, say, diathermy. I mean, it doesn't feel like your arm's being microwaved when you're taking the discharges, but they're definitely hot discharges. So, very interesting. A coil that produces many things at once, including the whole idea with the brush discharge forming the same time you're pulling off sparks. That's something you typically never see. The minute you draw the sparks, the brush disappears. So all because all of these events are happening simultaneously or at slightly different intervals. So you get things happening at the same time and things happening slightly different times. So the output kind of has things independent as well as together, and so you have different events and then you have a mixture of different sparks. So kind of an interesting setup. The sound's very cool. You get a lot of unusual kind of hit and miss engine sounds out of this. Up close you hear all sorts of strange sounds, and just a different coil, a different kind of setup, and kind of neat. Something unusual.